Hello, this is another educational video on using EES, and what we're going to do here is use EES to solve a process problem and looking at properties. This is very similar to material we would see in Chapter 3. So here's the problem we're going to solve. We have a constant pressure piston cylinder device. It contains 1.2 kilograms of water. We're given an initial temperature and pressure. Then we're told it's cooled to 50% of the volume, and that occurs at a constant pressure. We want to find four things: the initial volume in meters cubed, that's an extensive volume, the final volume, and then we want to go ahead and find the final temperature in degrees Celsius, and then also the final quality of the material. So let's go ahead and EES. Here's our equation window, and the first thing I'm going to go ahead and do is just put this directive in that the unit system is an SI, just to make that explicitly clear. That is the default. And then I'm going to go ahead and put a comment. These are my given properties, that T1 is equal to 250 and P1 is equal to 300. So that's my temperature and pressure. I don't need to write anything about the units down because that's a default in the system. And the mass is 1.2 kilograms. Then I'm going to put a comment in here just to remind myself that this is an isobaric process, which means that it's constant pressure. So now I can go ahead and tell me that the final pressure, which I'll call P2, is the same as P1. It's constant pressure. The other thing we're told is that the final volume is 1/2 of V1. So I'll just do that at V2 is 0.5 of V1. All right, so then now we can go ahead and just use EES to find some properties, because we have two intensive variables at the final state, pressure and volume. Those are both independent. So we can go ahead, and we also have two independent properties at the initial state, at temperature and pressure, and assuming that that is superheated, which it is, we could verify that by seeing that the temperature is higher than Tsat. We can go ahead and find our properties. So here I'll go ahead and find V1, the specific volume, using the volume function, and this is of water. And now I put in my initial conditions of P1 and T1. And then I can find the extensive volume. I'll call that Vol1, and that right there is the mass times V1. We also need to find the final extensive volume, so volume 2 is mass times V2. And we can go ahead and continue to find any other properties we want. So one of the things we need to know is the temperature. So I'll use the temperature function. And the two things that I know is I know the final pressure and I know the final intensive volume. We also need to find the quality. So there's a function called quality, and it's called the same way, water. And again, I'll use two independent properties, P2 and V2. So if I typed all that in correctly, I should have my solution. And so here it is, and so the things I wanted to find, my little v's here, those are my specific volume. Vol1 and Vol2, those are my extensive volumes, those are in meters cubed. I see my quality here at 0.65, so it's a mixture, and 65% of the mass is in the vapor phase. And the final temperature was 133.6. So what you realize is it's EES makes it really easy to solve these problems fairly quickly, because I don't need to look up any of the properties. I don't need to worry about what tables I'm looking at, A4, A5, A6. EES just goes ahead and does it for me.